In wave riding, trying to find the right waves at the right time is really a scientific exploration. There's a lot of information that is needed to sort of make the right choices to find the right waves at the right times. I'm John Warwick. I'm a research geologist at the U.S. Geological Survey, and I work a lot on coastal change here at the USGS. My experience with wave riding goes way back to when I was a kid. As soon as I could ride a bike, I was down at the beach all the time, riding waves, surfing, body surfing. Wave riding is really what got me interested in the ocean and in science. I often think of, as a surfer, I think of needing to be sort of knowledgeable about a number of sciences: oceanography, meteorology, geology, geomorphology, because they all combine to make up where the right waves are at the right time. Finding good waves is all about understanding, the wave conditions at any one time, but also the physical setting of the beaches and the coasts. I think about it in two different ways. There's the waves, the offshore waves, or the wave field that are approaching the coast. So the waves as they move into the coast, how big they are, where they're coming from. And then there's the other element, which is the shape of the coast, both way offshore and really close to shore, because both of those things influence how waves will break as they get along the shore. So the first element is the wave field. And one thing that surfers are really interested in, swell and where it's coming from and when the next swell is coming, etc. The ocean is actually delivering swell from all kinds of different directions at the same time. The waves at any one time are a combination of waves coming from all over the Pacific Ocean. So we can have waves coming from the north and the west and the south and contributing in different amounts at the same time. And it's really that combination of waves that produce the details of the conditions. Not only just wave size, but how the waves are breaking is really a function of how those waves are combining together as they approach the shore. We're able to understand and predict where waves are coming from and how big they'll be because we know that waves are generated by the wind, and that we're getting better and better models of wind fields across the ocean. We can see when there are storms in various places of the ocean and how those wind fields will generate waves, and those waves will move across the ocean and approach our shore. And again, those waves will combine in ways where you can have different types of conditions at different spots. So we have these waves approaching the coast, and when they get toward the coast, they start feeling the bottom, the seafloor. And that's a really important aspect of sort of where the waves will break well, is sort of how they feel the bottom of the ocean, and how that the bottom of the ocean actually kind of modifies the waves. It changes the waves. The classic example is Mavericks up the coast, or Steamer Lane, or even Pleasure Point here in Santa Cruz, where we have these offshore reefs, these offshore rock shelves, and those focus the waves onto a certain spot. And so the waves at that spot, where the waves are focused, are much bigger than in adjacent areas. So that's one way that sort of the morphology of the shelf, of the offshore bathymetry, influences the wave field. Another way that the offshore bathymetry, or the water depths, the shape of the shelf, will influence the waves is the way that waves break. And so waves break in sort of different ways, and that's generally a function of how steep the seafloor is. And so where the seafloor is really flat, waves will sort of come in slow and crumble. We call that a spilling wave, where the wave doesn't break very fast. And an example locally is like Cowles. And so when a wave will come through and spill slowly, it's a very gentle place. It's a good place for beginners to learn to surf, or for longboard surfing. It generally is a slower wave, a safer wave. And as the seafloor gets steeper and steeper, we'll get plunging waves. The waves will overtop and make a barrel, a tube, which is obviously something that surfers are always looking for. But you could see, you know, once you get steeper, it can overtop even faster, and it can get dangerous. And so we're always sort of trying to find places where that slope is just right, not too slow and not too steep, so you can get that braking just right. Another aspect of how waves are influenced by the seafloor is by, in a sense, how long the wave will be. There are different types of coastal settings, from beaches to, you know, rocky shorelines and coral reefs. And each of those different settings will have an influence on how the waves break. Because the seafloor is really important for a number of things, habitats and resources, and of course in surfing for how the waves will transform to the coast, we've done a lot of mapping of the continental shelf to try to understand its shape and its morphology. And that's primarily done using sonar systems that are deployed from boats, and they send signals to the bottom of the ocean, and those reflect back up. And from those signals, you can interpret the shape and morphology of the shelf. And those types of data have been really important in terms of understanding where various resources are, but also, you know, how waves transform as they come to the coast. That type of data we've collected up and down the coast, and it can be useful for understanding waves and other marine resources. One of the tricky things in collecting these data is getting it real close to shore. And so if you look at the maps of the offshore bathymetry, you'll note that there's typically regions closest to shore where the waves are breaking, where we don't have a lot of data. And that's just because it's really hard to get in those regions. There's a lot of kelp. It's often not a safe place to work because the waves are breaking. And so it's been really challenging to get good data right in the surf breaks to know exactly what the seafloor looks like there. And so we do have a gap in our data and our understanding for what the seafloor is like right in those surf breaks. Another interesting element to the bathymetry and how it influences waves here in the Santa Cruz region is sort of the way that the shelf has evolved over time. And here we have this rocky coastal setting. And on top of that, we've had tens of thousands of years of evolution of that include during the ice ages, when the glaciers were up on the lands, the ocean was much lower than where it is now. And many of our rivers along our coast were carving through and forming valleys way offshore. So, you know, what's under the water now was on land. And we had our rivers carving through that. As the ocean is now much higher, we still have those channels carved into our offshore platform. And those channels can be seen in the data we collect. And they're also very important for influencing how the waves are breaking along the coast. And some of our more popular surf breaks, like Natural Bridges, 4 Mile, Scott Creek, and even Steamer Lane, are all formed on sort of the walls of those little canyons. And so one of the interesting things to think about, those surf breaks are actually formed on sidewalls of river valleys, and that of course have been changed with time because of the waves modifying them, but really are a function of sort of river processes during the ice ages rather than current conditions. One of the really neat things about being a scientist and a surfer is that every time I go surfing, I'm actually doing a little science. I'm thinking about, why are the waves doing the things they're doing today? And it really relates to all those factors, the oceanography and the meteorology, the weather, what the shape of that seafloor and the shelf offshore are. Because every day is different, it provides a new sort of data point for me to think about how waves react to all those variables.